So here is the answer to my second question, which was to sketch the graph of the function y equals x squared minus 2x plus 10 by rewriting it. So I'll start off with my x squared minus 2x plus 10, and I'm going to take the coefficient of x, the x number, which in this case is minus 2 because we've got minus 2x, and I'm going to halve that to get minus 1. I'm then going to take that minus 1 and I'm going to square it to get 1, because minus 1 times minus 1 makes plus 1. And then I'm going to take that 1 and use it to rewrite the 10 as 1 plus 9. So everything else is the same here, the x squared and the minus 2x, but I've rewritten the 10 as 1 plus 9, and I got the 1 from that process that I just described. Well, the advantage of that is that part of that expression is a perfect square. If you take the x squared minus 2x plus 1, you can actually write that as x with something in a bracket all squared. And in fact, it's x minus 1 all squared, and you can get the number that goes in the bracket easily by just taking the coefficient of x and halving it. So we had minus 2x, half the minus 2 is minus 1, and it's minus 1 that goes in the bracket, so the bracket is x minus 1 squared, and then the 9 that was already there. Well, the point of that is that we can now use it to figure out what the graph looks like by considering how it's transformed from the basic graph of y equals x squared. So we know that the basic graph of y equals x squared looks like that. So the graph of y equals x minus 1 squared will be the same graph but shifted 1 unit, not to the left as you might expect, but actually to the right, so that the vertex is at plus 1. So even though it's x minus 1 in the bracket, the graph has a vertex at plus 1. Then we've got the plus 9 on the end, and that causes the graph to shift upwards by 9 units. So up it goes by 9 units. And then when it gets to where it's supposed to be, it has a vertex at 1, 9. So the original vertex was at 0, 0, and then once transformed, it has a vertex at 1, 9 because of the shift of 1 unit to the right and 9 units upwards. So the graph of the function y equals x squared minus 2x plus 10, we can figure out by rewriting it, looks like this with the vertex at 1, 9. And it might be interesting to just verify that in GeoGebra. So here we are in GeoGebra, and we're going to type into the input box at the bottom y equals x squared, so that's x and then control 2, minus 2x plus 10. And it gives us, well, we're going to have to move the axes to find out where that graph went. There it is, up there. And we can just click on point to find out where the vertex is, so the bottom of the curve, and it is indeed at 1, 9, as we predicted.